So, yeah, thanks, I guess. So the invitation today came from Kerry Mangerson, who I've known for years and years, as I was saying, through the statistics community. And I guess she's absolutely followed an academic path in statistics, and I've followed an industry path where I've now moved to leading data science teams and setting up data science teams in industry. So what I'll talk about today is, I guess, hopefully I've gotten the brief right, is to sort of demystify what is data science, what's all the hype about, and what are the sort of skills and types of projects that students would be asked to look at in industry, or if you are going to partner with industry, what sort of projects might they want to partner with you on. So hopefully that's right. And we're finishing at 12? Yeah. 12 Brisbane time? Yep, okay, great. So I'm just sort of going to run through a few introductory slides that are all, it's open source material on the web, so it's nothing I've created, but I've tried to pull together the story. So if we start off with this slide, I don't think it's any surprise to anybody that more and more data is being collected in the world. For those who have teenagers, the one on the right, or the blue one, is a very good dinner conversation about how many emails and tweets and YouTube videos are loaded up every minute of the day. And all of that, when we look at data, perhaps in a traditional way, you would look at tables, SQL databases, numeric data. But now, the world is a lot about video, text, free text, images, etc. So the skills that a successful data scientist needs are not just in numeric data, but in lots of different types of data. And then an interesting fact I often bring up is that on the top left-hand corner of the grey slide is that 90% of the world's data has been created in the last 2 years. And so data, as I've said, is not just numeric and tabular data, it is images, etc. So absolutely, people who can have the skills to analyse and get information out of this data are in hot demand. And then what is happening is the red line in this chart shows what we're witnessing, that the world is producing more and more data. It's cheaper to produce, it's cheaper to store, and so it's being produced, but a lot of organisations following the black line are really not using that extra data. So there's a massive gap and a massive opportunity for people with the skills and organisations that are willing to invest to close that gap and really get the most out of their data. And the study that was done, which I can send you it's got the reference in the notes, that only 12% of execs feel that they really understand the impact that data can have on their organisation. So again, massive opportunity. Now what this slide is, apologies for the bad graphic, it's actually a Gartner slide, if anyone reads the Gartner literature. So it's one of the leading, so it's Gartner, and they're a sort of market research company, but they focus on analytics and data science. So they rank which are the top software products, what are the top skills that people need to have. And this is a really useful chart. It shows how mature an organisation may be. So this probably wouldn't apply to universities or university research. This is the applied side in an organisation. So if you look at the bottom left-hand corner, where what the analytics can do or what the business is doing is of lower value and low complexity. And so this is reporting. So traditionally you would report how much, if I'm thinking with TEAS, how much coal was moved on such and such a week, what was the productivity, what was the maintenance cost. So these are just saying what happened. So it's really, I guess in statistics land, you'd often call this exploratory data analysis. So just the very basic reporting back of what happened. And then you would then move to the analysis part of why did it happen. So, for example, if the maintenance costs go up, you might deem that perhaps they changed the brand of oil in the truck, or it was a very rainy week, or it was a brand new crew and they weren't as well trained on the truck, the roads might have deteriorated. So that's sort of the next step in complexity and skill needed to do that, and also the business gets more value out of that. Moving to the next one out, once you know which are the factors that you need to that are having an impact on your productivity, you only monitor the, say, 3, 4 to maybe usually half a dozen that are going to tell you what is happening now. So if you do determine that weather was an impact and perhaps deteriorating roads, you would set up a monitoring system to only monitor those couple of things. And again, that means you can act in much better time than if you're just reporting what happened. And then the holy grail that a lot of people want to get to is prediction. So what might happen in the future? And I guess all of us that have worked in modelling and predictive statistics know that we can do that, but it takes a lot of organisational willingness and trust, and also very, very good data systems to be able to get to that point. And in my life experience so far, Boeing's the only company I've worked for where we've gotten to that stage, and I've got that example in the slides a bit later on. So I find this I use this in all my talks and when I talk to companies, because it explains the maturity. And then when for those working with industry, you can go straight in and assess where is that company or that organisation on this scale, and be very honest up front about where they are. Okay, I won't labour on this slide, and I don't think it's any secret to anybody that the demand for data scientists is increasing dramatically, and all I did was a Google search on demand for data scientists, and you'll see there's Forbes articles, PwC articles, and basically saying, even the top one says the demand will soar by 28%, and some people have said it's been 300% in the last 2 years. So again, really great opportunity to tap into firstly the need of organisations, and then the fact that a lot of people will be seeing this as sort of the job of the future, and how do I get trained in this job? Okay, not that you trust Wikipedia for everything, but I wanted to do a search on Wikipedia because data science means a lot of different things to different people. So here I've just underlined the word. So some people say mathematics is data science, statistics, information science, computer science. And again, you see, look at all these terms that have been used to define what data science is. And again, it still possibly is a bit of a mystery. And then Harvard Business Review have said it's the sexiest job of the 21st century. So I'm pretty happy that I'm in the sexiest job of the 21st century. But again, it's a really exciting place to be. And so what I have done, I've done some research on which universities offer certain programs, and I don't think I've actually got QUT on it at the moment, but I just did a very quick research, and I'll just scroll quickly through, but just to show you that many universities now offer a data science degree, and first they used to offer masters or a grad dip in data science, but there's no consensus on a curriculum or a definition, etc. And so different universities, you will come out with different qualifications on data science. So again, showing there are so many different definitions that data science has in the world. Now, this is sort of, to me, the crux of what data science actually is. So these two Venn diagrams essentially show the same thing, but they just use different terms. So if you look sort of in the top left there, so it says mathematics expertise, and in that I include statistics. So people who can actually write down models from first principles and work out, does this violate assumptions of certain models? Or so, for example, I'm doing some work on safety data at the moment in TEAS, and because it's count data, the person in safety had been coming and they'd been doing a straight out regression, and so I could say to them, no, you don't do a straight out regression on count data, you need a GLM. So it's people that can have some of that mathematics training and can actually point companies or make sure that you're using the right model. Another skill that's absolutely necessary is the technology, the hacking, the computer science skills. So people to pick up roles in industry and to be successful, they need to be able to code and to be able to we call it munge, I don't know if you use that word, munge databases together, and to be able to wrangle, data wrangling, etc. Because the world out there now, it's not a perfect, I know when I went through uni that we got a perfect SQL database and off we went, but now you might be pulling in video data with weather data, with images, and then with millisecond sensor data coming off a machine, and you have to try and blend all those together. So the technology and hacking and computer science skills is absolutely necessary. And then the bit that a lot of people may get wrong, and a lot of businesses get wrong when they hire people, is having some sort of business acumen or being able to talk the language of industry. So I've seen some people who are very, very clever in the top two circles and get hired because of that, but then they get into business and they've either had no training or no leaning or intention to want to be able to speak the language of the business. And by that I mean, if someone comes to them and says, can you please model the maintenance cost historically of this truck, and they need to be able to say, well, what's it costing the business? What will be the benefit if I improve this by 5%? What will be the benefit by 10%? So you need to draw out what the business problem really is first before you start to race away and start coding. So, and then in the middle, you've got a data scientist, and we often get called unicorns. So if you've got all the three, you've got a really, really sweet match. So again, at university, subjects like statistical consulting or communicating, I know like there's subjects where you do projects and you have to communicate the results of the project and the why of the project are really, really valuable in this area. Okay, again, I'll leave all these slides with you, but this is a neat little slide of about, I'm part analyst, part artist, and so they also need to have some kind of creativity about how to make the results they've come up with appealing to the business. So some businesses like just complicated charts and some like sexy dashboards and whatnot. So they also need to have some element of creative thinking as to what would be best for the business. Okay, I probably won't labour on this slide too much, but essentially it shows you at the top so this is the cross-industry standard process for data mining. I think that's what CRISP stands for, and that's how a lot of organisations run a data mining project. And you'll see at the very start there is business understanding is really the critical point to start, and sometimes that can be 80% of the effort, the business understanding, probably coupled with the data understanding. And you'll see sort of the modelling and evaluation comes quite late in the process. You don't sort of race in and start modelling. You do the business understanding and data understanding, which I guess is the same in research. You form a research problem or a hypothesis and make sure you know the why of what you're answering. And then this chart also shows that it can be a cyclic process. So you could come up with a model and then they go, oh great, that answers this, but it's also shown that it might be the engines are overheating on the truck. So we've worked out that weather is an effect. Thank you for that. But in your model, it showed that engine overheating is a factor. So then you would go back to the business understanding and go, why are the engines overheating? And then go round again.
I suppose it's that understanding how not only coming to a solution, but how it benefits the business. Like what's actually impact. Sometimes you don't need a perfect answer. You just need a better answer.
Yeah. And that's often sometimes I've had quite a few postdocs in my teams, and they often want to get a 99% perfect solution, and that's another thing in industry. A sort of 70%-ish is usually okay, because it gives them an indication of where to look. And then if they know where to look, then they may do a more refined search in that area rather than getting a perfect answer straight up. And then what I wanted to bring up is that the trend is to go to open source tools, and so students who have experience and who are skilled in open source tools. So I know when I went through, it was a lot about you learn SAS, SPSS, Jump, so all the sort of commercialised products. Now the tools that are useful to industry and that make candidates marketable in job interviews are all open source tools. So I'm not sure if you guys teach R and Python and stuff like that.
Each of the nodes are different and have different spectrum of skills, and some of the nodes focus more on R. Lots of R, and so ggplot.
Yep, I love ggplot. Yep, yep.
And so it's varied across the network, but mostly open source.
Yeah.
People are using proprietary tools.
Yeah, exactly. And it's the same in industry as well. Probably the only proprietary tools in industry more are in the visualization stream, so that green one. So the Tableau, Power BI, and Spotfire. They're the sort of a lot of organisations have been dazzled by the shiny marketing and dashboard, and they've bought them, but they don't necessarily know how to drive them.
Yeah.
But because so in the green one, that's where the most proprietary software is in industry. But the rest is, if you can do R or Python, you're definitely employable. Yeah. Okay, so this just very quickly, who is offering what? So given that I've led in saying that data science is a very hot job in the market and people are looking to upskill or start a degree in data science, I'm not even going to labour on these. I'm just going to go down, and you'll see a lot of so there's Deakin. Deakin actually have a really strong online presence. I think they've really got the market with online at the moment. Deakin, Monash, UWA, Curtin, UNE, Murdoch. I apologise if I gave up after a while, but you'll see they're everywhere. And if you do your own research into that, you'll see what they offer varies a lot. Some of them are run out of engineering departments, some are run out of IT departments. Actually, most are run out of IT departments, and sort of the maths stats often just teach a couple of modules, and so it's not necessarily a partnership, which I believe it really does need to be a partnership between two faculties, given that diagram of the three circles. So so the message here is that a lot of and I've just done the Australian universities half an hour search are offering courses. I can send a matrix actually to someone, maybe Claudia. I've actually done a matrix of university by subject, and so you can see the commonalities, and I've written some comments on that, so I'll send that to you after this. Yep. I actually did that for Wollongong University. I'm sure they won't mind me sharing it. So and then another trend that's happening, which I think is a risk to universities perhaps, because people are looking for a quick fix to get a qualification, and for myself and others as people who are hiring data scientists or recruiters to not get caught by people coming in, particularly the MIT one there. I think it's a 6-week data science course, and you get a certificate at the end of it. And so a lot of people are putting on their CV, I've been to MIT and I've done data science. So people, looking for a quick fix to get that on their CV, and then especially some of the very high branded universities offering, they're making a killing out of that. MIT 6-week course. So I often recommend these to my colleagues who want to learn more about data science, but I also say be wary of recruiters when people say I've got a data camp certificate or a data quest certificate, that it's an online 6-week.
Are there some skills that you value more from a university compared to something like data camp?
So data camp is more almost gives a talk like I'm giving now. So what is data science? How can it be applied? And it gives examples of, say, here's R, and you use this, LM command or this one command. It doesn't teach them how to critically think. So I think the thing that universities offer is that it teaches you to critically think and break problems down, and, the parameters that are on the standard library, you may have to adjust them because this data doesn't meet that. So you look at programming skills in data camp might look more favourable than statistics skills in data camp, for instance. Yeah. So it definitely doesn't go deep enough into the statistics and modelling skills. But there's a lot of, I taught myself R on YouTube, so those sorts of things, it's okay to do online, but it's the analysis. So when I'm interviewing people and I say, can you just tell me about a project you worked on? And they say, I predicted, the risk factors of lung cancer. And you say, what method did you use? And they give a method. And then if you keep questioning, someone that's just done something like this, they've only got one. So random forests are really popular at the moment. Yeah. So a lot of people in interviews go, I did random forests. And I go, and then they don't have anything else to go from it. Whereas someone that's had that deeper training can go, well, I also tried clustering, or I tried adjusting the depth of the tree, or something like that they've put some critical thinking into it. So I guess in a way I see this as a little bit of a risk to universities, because people gravitate to the easy option. And so then I also speak a lot to professionals in the industry and say, be careful of these. So I just wanted to raise that. Okay, so now I'm going to talk, and I don't know if anyone wanted to ask questions on the material so far. Otherwise, I'll just launch into problems that I've worked on in industry. So any of you guys know Ken Russell, who used to, I think he's at Charles Sturt now. He was at Wollongong. He was my stats lecturer when I say growing up, when I went through undergrad. And he used to throw out chocolate frogs if people answered his questions. But I'm going to try and make this a bit more interactive, but I don't have any chocolate frogs, sorry. So
I don't know if we can
hopefully,
I don't think we can teletransport them.
Yeah. So I'll go through these, because I can't actually put the results and the charts and whatnot up, but I can still talk to what we did, and hopefully I've got enough diversity in the problems to spark people's interests. So the top left-hand one was actually a medical research project I worked on. This is called a polar probe, and it was an alternative to pap smears. So that little silver thing at the top was like a laser, and it just sat on the uterus and took readings. And so then, again, as data scientists, the job was, how do we classify cancerous versus precancerous versus healthy tissue? So that was a really interesting project to be part of. And the problem, so unfortunately the company went bust, so it was a sort of an R&D startup. We got the model prediction correct, but they couldn't commercialise it. So because there are all sorts of things, obviously they had to sell sheaths and covers, and they just couldn't commercialise it. But as far as a data science problem goes, it was really interesting. So, and that was an image analysis problem. So you would get an image of the uterus with all the little cells, almost like what's under a microscope. And then you would also sort of get various sort of, acidity and other types of readings that we tried to predict what was going on. Okay, the next one, the cricket one, this is usually where I throw out a chocolate frog. Does anyone know which cricket oval that is? Did you say SC?
I don't know.
No. Does anyone?
I didn't know the GABA.
Is it the MCG?
No. So it's actually Adelaide Cricket Oval, and then I say why, and it's because of the heritage scoreboard that you see in the background. And so what happened at Adelaide Cricket Oval when they started day-night tests, because it was a heritage ground, they weren't allowed to put permanent light poles up. So they designed retractable light poles, so a bit like telescoping light poles that would retract up for the game and then retract down into the ground. What happened though was the first game they put them up, they got stuck. And so I was actually a witness, a statistical expert in a court case for this one. And so you could imagine the Adelaide Cricket Trust sued the manufacturers, who sued the designers, who sued everybody. There was this massive legal court case going on, and they brought me in to try and find out why the lights got stuck. So again, this would have been another chocolate frog. If anyone can have a guess or a think of what sort of things we might look at to do that.
Temperature?
Very, very close.
Rain?
Close?
Humidity?
No, you're on the right theme, yeah. What else do they measure in meteorology data?
Wind?
Yeah. So what happened was, if I can demonstrate, so the lights were designed at ground level, and so they did take into account the distribution of wind and the distribution of weather at ground level. But the distribution of wind when you're at height is much higher than ground level. And so what happened, they telescoped up, and then they sort of all blew against each other and wouldn't get down, wouldn't get stuck. So so that was a victory for statisticians that we could work that out. So that was a very expensive court case. I don't know how it all played out, but even if you wanted to look later at some of the saga of the lights at Adelaide Cricket Oval, there was a statistician involved in that. So that was an interesting problem. I don't know if people knew, back in the 90s, BHP was going to buy Telstra. Back in the day, and so the problem I was asked to look at was to compare is when the resources stocks are up or the resources prices are up, what is the telecommunication prices and usage doing? So they were trying to sort of hedge their bets on having one perhaps being up in a cycle and the other one being low, and then when resources dipped, does telecommunications increase? So that was a very big commercial problem. So you see even already on this slide I've gone from sort of a medical research problem to a court case or an engineering problem to now this being like a sort of a merger and acquisition problem. And I guess we all know what happened because BHP didn't buy Telstra. So for whatever reason, they decided not to do it. And then the last one I've shown, so this is one of BHP's mines, Olympic Dam in South Australia. And what was happening, I still don't know if I get the terminology right, is that the ore was being picked up, so that's called a reclaimer, that big wheel thing, so it's the buckets that scoop the ore up. And what had happened is it had been sort of put into maintenance, and then it started tipping the material out backwards, so they were getting a lot of wastage. So if you was, say it was trying to, I don't have a whiteboard, so trying to scoop things up, and what would happen is that it would tip out the back of the scoop, and then again got called in to try and work out what happened. And all it was is, if you imagine the tangent on a circle, so you've got a circle and the solution is minus b plus or minus, and so someone had chosen the plus intercept and it actually should have been the minus intercept, so they put the bolt in the wrong spot, and by doing that it tipped out backwards instead of forwards. So something again that all the engineers and all the maintenance people looked at it, we go, we don't know what's going wrong. You can really strip the problem right back and go, what is really going on? And it was literally as simple as the tangent on a circle. So that was, something is, so if for people who are teaching and students go, why are we learning this? It was millions and millions of dollars was being wasted because someone put the bolt in the wrong spot. Yeah, and it was tipping all the ore out backwards. Okay, here's some examples. So I was at Boeing for about 6 years working as a practicing data science statistician, and then moved into management. And here's a couple of examples that we worked on while we were there. This is usually a chocolate frog question. What the top diagrams show is the interior of a 737, and while I was working there, the marketing or the commercial department was going to redesign the interior of the 737, and they wanted to do a study that they could sell to the airlines to say, we have worked out that people will pay the most money if the cabin has these features. So if anyone who's been to Seattle, to the Boeing factory, as a tourist, for a period there they set up mock cabins. So the tourists would go through, and they get hundreds of thousands of people a year go through the factory. They'd go through their tour, and then at the end they would all sit in these mock, sort of I think there was 6 mock cabins, and then asked to fill in a survey of, would you pay $50 for wider armrests? Would you pay $100 for bigger windows, say? So all of the features on the inside, and we used conjoint analysis to solve that. And so again, does anyone want to have a guess, or it might be a bit hard because we're all on VC, of what the main feature was that that came out of that quite strongly, that people would pay more money for? No, because I guess the legroom is then more to do with the airline. Yeah, so. But yeah, I would certainly pay more for legroom. Yeah. But you're actually on the right track when you're talking about room.
We've got some suggestions here.
All right, yep.
Well, someone already said legroom, but you said no. But what about the amount of space between your head and the overhead leg?
Bingo. So the way I would describe it, so I need to get all these virtual chocolate frogs. The way I would describe it, you see in the, and for those of you who are going on flights in new 737s, look up, and it's the sense of height and space and feeling like you're in more of a sky or a natural environment rather than being cramped down into a tube. So yeah, absolutely, it was the head height and sense of space. And then you'd probably also notice now that airlines change the lights depending on the time of day. So it's that sense of feeling like you're in a more normal environment. And then another interesting factor was I met the data scientist for Delta Airlines while I was working at Boeing, and they did a study on sort of customer satisfaction, and the biggest thing that came out was clean the windows. So they didn't care, if the nuts weren't that good or the drink selection. It was clean the windows. Again, it's that sense of space in an aircraft. So that was really interesting. And then the other one was, again, when you're on a flight, if you look at the panels next to you, you'll often see different airlines have different coloured paint and different patterns on the panels, sort of the interior panels. Each of those have been chosen to minimise lightning risk because they all have certain flammability ratings. And so there was someone's job at Boeing, which sounds like fun but would be really boring, was to set aircraft panels on fire all day, every day. So they had this big screen with so they'd set a different paint colour and a different pattern, and they'd set that on fire and then work out which were the most and least flammable. And that was it was a very big design of experiments problem because it was expensive to set aeroplane parts on fire. The less paint, the better, and the less metallic, the better. So, yeah. So anyway, just when you're flying, just take a little look. So again, I guess Boeing's a big company with a lot of problems, and already here's two very interesting problems solved by two very different techniques. And I guess in all of these two, I should say, we didn't work in isolation. We had the design engineers or the marketing directors with us, because you'd come up with something and then it's almost like the sniff test or the pub test. And not that you falsify your results by any means, but they certainly help you each step to guide you through, so you don't start going off and get this beautiful analysis when they said, actually, no, this one makes more sense. So that one. Right, okay, so something that's becoming very popular is data visualisation, which you possibly heard about. So this is just a quick example I did when I was consulting. So Water New South Wales own the dams or run the dams in Sydney in New South Wales, and they every week they send this very exciting report around to all the stakeholders and the public. This is publicly available, so the public can go and look at it. So you can see in the bottom table, it's got every day, what's the temperature, what's the rainfall. The bulk water supply is how much water Sydney uses, how much storage, etc. So I got, I think it was 18 months worth of these, and converted those for this, so the water supply for how much water Sydney uses into that. And so there's actually 3 trends going on in this chart. So what we're seeing is the day of the week along the x-axis and the time of the year, months vertically. And the more yellow, the more green means the more water that Sydney used in that particular period. So again, if people have a shot at what the 3 trends might be. I hope I explained that okay. Yep. Did I? Yep.
Yeah, we've got there's public weekend, people water more, water the garden.
Yep.
And then we use more water.
Yep, so definitely, so the Sunday or the weekend trend, so do they fill up their pools, wash the car, have longer showers, do the washing, water the garden, etc. And so that trend is quite clear in this chart, but however many weeks, 52, 75 weeks of that, you would never see that, even though that is reporting accurate data and it's all very correct. But to look at it in a different way, you see the weekend trend which then may change some of their procedures with that. And I think everybody would notice the big yellowy green stripe in the hot months in summer.
Yeah.
But then when you look at January 16, it's not. You would think, it's still a very hot month.
Back to work.
Or holidays.
Away.
Yeah, so I actually only picked, when I first did it and I sold it to Sydney Water, I only told them the first two. And then I was just in this talk at BHP and it was just one of the data entry people up the back. She said, well, what about January? So she picked up that, is it back to work or holidays in January? So I think the beauty of a chart like this, I think the theme of the chart looks like water. So this is again where I say part of the magic of a data scientist is to be a bit creative and to be able to sell what they're trying to show. And the fact that you can summarise daily data for 18 or 15 months into a single chart that non-water experts and a lot of even sort of say the general public would understand what's going on there. So visualisation's a big theme. And again, this is this is a Sankey plot. So it's actually showing multiple dimensions. So these are all the dams in New South Wales, in Sydney. And so the location of the label is the location on a map. So if you wanted to be more clever, you could perhaps overlay a shadow of a map behind that. And then the width of the line is how much storage that dam has for Sydney. So again, it's very clear. You can see Sydney has a pretty big single point of failure. If something was to go wrong at Warragamba, yes. So this is often good in looking at, if you've got a cohort of patients and what's happening if some of them are smokers, non-smokers, exercisers. So you can actually break down your cohort and show it graphically.
Is the colour coding a variable?
Yes. So I didn't make it, I didn't adjust that. So here I've used, location, I've used, the total storage, and I didn't use colour coding, but you can. So you could colour...
but this one doesn't have it. This one, the colour's not coded.
No, this one, the colour's not coded. But you could, I'm just thinking, for example, if some dams, say, have spillways and some don't, you might want to colour code the spillway dams, navy, and the other one's light blue, so you can bring colour in as well. So you can often show sort of 4 or 5 dimensions of a data set in one visualisation. Thank you, plot. What's also becoming really popular are interactive maps. So this is one I did at Transport. I don't know, I can send it to you and you can open the link. But what this shows is the size of the bubble is how many people use that train station daily. And the colour of the bubble is how much has that changed over the last 10 years. So, and I didn't put any of the city ones in there because they would take up they would just mask the entire map. So what we're trying to, and what you can do, you click on that and you can zoom in and out and you hover over it, it gives you all the stats for that station. You can slide around to whichever area you want to. What we're trying to show here is for the Transport Department in New South Wales, are there any growing hotspots, growing population or growing station use that we haven't planned for. And so what you can see is, and unfortunately that's where I lived in Sydney, I don't know if you can see we're at Newtown Marrick, that's near Sydney Uni, for those who know Sydney. Look how much it's not a massive patronage, but it's really red in that area, and that's an area that's gentrifying quite a bit, and so there are definitely problems with crowding on that line. And another interesting thing, if you look way out to the west, to the left, the blue is showing that less people are using public transport. So something's happening, people are frustrated or they want to drive their cars or something, and that's also causing a lot of problems in Sydney, that people are driving in from the west and it's just choked.
Driving into the red dots.
They're driving into the red dots, yeah. So, and then the sort of orangey big dots, that's the new Macquarie Uni line. So we didn't pay much attention to that one because it's the Olympic Park of Macquarie Uni. So it was starting from 0. So that's not such a big deal. But the big deal is where the red dots are and have they planned for it. Yeah, so it's interactive, and people like to be able to sort of self-service their information without touching the data. Like, you don't want them to touch the data. A very hot topic too is self-service dashboards. So again, this speaks to the visualisation. So even in this, if you look at this sort of bubble plot in the top left, there very well may be a very clever clustering principal components analysis model behind that, but what you need to be able to show is the so what of that model and what does that mean for the people using it. And these things, people like interactive, so you might click on that top sort of beige bubble and then it shows this is a certain, I don't even know what the chart's about, days in pipeline productivity. So you might click on that and it might, if that's a project management type chart, it might show you what types of project sit behind that, and then there'll be another chart that sits behind that. So yeah, again, people like to be able to self-serve themselves with information, but trust the models behind that. This is a really neat one. It would be great if you wanted to look at that. This is the, and this one, I think, a visualisation prize. This is the US budget, and so the size of each of those rectangles is the amount of budget that has been allocated in the US. And again, you can click on each of those and it just keeps drilling down and down and down. But you can see very, very clearly what the big hitters in the US are. What is it? Medicare, Social Security. Yeah. Has anyone seen this chart before? No? So this won an international competition. So what this is showing is, so it's the states of the US on the vertical axis, and it's the incidence of measles, the disease measles, over time. So from 1930 to 2000, and you can see, and then when the vaccine was introduced as the vertical line. And so you can see, I think it's pretty obvious, sort of the higher incidence to the left of the vertical line introduced the vaccine, and then look at that. And so traditionally we might have seen, say, a line chart with 50 lines on it, or various other, I guess, more traditional charts that are trying to capture 3 and 4 dimensions, whereas this one is really, and there's actually an R library now that does that. So there's actually it's called a waffle plot. And so, as you can see, it looks like little waffles. And so some clever person invented that and then made that's what the beauty of these open source tools are, and then made that available. And so I've used that same chart on electricity when all the South Australia electricity issues happened in that storm. So I used the same chart on failures of each substation over time in South Australia. And my axis was the distance from Adelaide, was what I had on the bottom axis. So you could see in the chart that as you went out, they were getting less, they were being maintained less and less. So it was showing that as an issue. So again, another clever way of doing data. Infographics are becoming popular. I won't labour on this, but again, it's the actual stats behind this are not that detailed, but there's a lot of people wanting to use infographics for things. This we did when the George Street in Sydney was going to be shut down to build the light rail, which apparently is an absolute disaster at the moment for those living in Sydney. But we did this so the politicians and journalists and the public all had the same figures of how many people come into the city, what's the contribution to the economy, etc. So another big project I've worked on, this talks to the big data theme, is a smart cities project. So what we looked at was, there's Google Maps is one of the providers of data, or that people's phones ping and they get a lot of location and traffic speed data from that. There's a company called Here, Here, which I think is now owned by Mercedes, or the European car company, that does exactly the same thing. So we had hundreds of millions of records. I think it was every 5 seconds of Sydney traffic data for a certain period, and to try and answer questions like where should we fund to improve the airport. A big issue in Sydney is that trying to get over the bridge and up north, and so are the conditions getting better or worse, or how can we change people's behaviour? Is people in cars affecting the buses? So if everyone's driving because they use the same road, are the buses also being slowed down? So this is just an example of a few questions. There's so many that could be answered. And then what we delivered is this, but behind this, so you might see that innocent 234,180, there were a lot of regression models and prediction models behind that.
And so when you work on a project like this, do you work with a graphic designer?
Yes, so a graphic designer. Yeah. So in my head, or in the head of the people we're working with, we say, we want to show this, this, this and this. And then I have a fantastic graphic designer, and she works mostly in sort of the R&D graphic designer space. So she works at communicating sort of complex concepts in a graphically appealing way. So yeah, she's brilliant. So yes, so Nat did that. So we produced we did the word cloud based on media. We produced the charts in R, so that's a ggplot chart there, and the map as well. And then she did the software that sucked them all in. Yeah. And so this is actually interactive. So you could drill into say the cost of congestion and see it's got heavy vehicles and light vehicles. You could drill into that by intersection types and etc. So again, it's showing people want information quickly, and they want it accessible and digestible. So it's a pretty strong theme. But behind each of these was a hell of a lot of data science and analysis. So there's hundreds of millions of records trying to come up with sort of predictions of how do we measure the cost of congestion. So we looked at the fuel cost. We even put a carbon cost in some of it, so the carbon emissions of people sitting on the road. We looked at sort of the Treasury have a standard value of people's time. So if the value of your time is $30 an hour to be sitting in traffic, you add all of that up. You assume what's the occupancy of the vehicles, but you look at what's the occupancy over various times of the day. So those assumptions would change. So yeah, I could go on and on, but there is a lot of maths and stats and data science behind this very pretty looking chart that the client loved, but without needing to know but trusting what was behind it. Okay, and so I think this is my last example. That's good. So this is the most, I would say, really one of the most advanced data science projects I've worked on. And this was when I was working for Boeing in Seattle. Someone came up with the idea, instead of only using black boxes when a plane crashes, so for catastrophic events, the black boxes actually collect data in real time and they just overwrite themselves. So we came up with the idea of the aeroplane pinging the black box data to the ground and then having a set of algorithms behind that predicted if this is happening, then you've got 5 flights before, say, the oil is going to need changing. And so we had every flight of every 777 and every 747 ever, which is, again, a perfect world. And there are 20,000 possible things that can go wrong on an aircraft. So it was a 20,000 variable and the data was all zeros and ones. So it was yes or no. So was the alarm on or wasn't it on? All zeros and ones. And of those 20,000, 1,000 of them are no-go for the plane. So if one of those 1,000 is on, the plane can't take off. So we had to try and work out which of all the zeros and ones matched each other and predicted. So it's a very binary problem. And then also overlay that with what is the cost, again, cost of people's time, what is the cost of a delay, what is the cost of rerouting. So if the plane is in the air and the airline says, oh, you're going to need a major air conditioning rehaul, don't go to Alaska, go to LA instead. What's the cost of doing that? And even, it's interesting, I think it's $20,000 a minute to have an aeroplane sitting idle on a what do you call it, the apron of the airport. So that's what are the airport fees. It was a very, very complex problem, but heaps of fun. It took us 3 years to solve it, but we cracked it, and now Boeing sell that by the hour to airlines to have that going on. So this, again, I don't want to labour on this, but this is all the architecture, so the E-enabled plane, and then there's all the sensors, and they talk to each other. And the bit that we did was the health diagnostics bit there. And out of sort of the 20,000 variables and the millions and millions of flights, we probably only came up with 24 predictors, but they were so strong that they're a product now. And so again, this is, I don't know if anyone wants to guess. So this is a coffee machine. That's supposed to be a picture of the coffee machine, and the toilet lights were strongly linked to something quite major failing in 5 to 10 flights. So I don't know if anyone wants to have a guess or a...
Smoke machine? Smoke detectors or something?
No, not the bathroom. It's not something, and that's I think the thing about data science as well. It's something. Yeah, exactly. It's something that is that you wouldn't necessarily pair these things with.
It's when the coffee machine's broken.
Yeah, when it starts to play up.
And the
Toilet lights are sort of flashing and intermittent. Yeah.
At the same time? Or
Yeah, at the same. Yeah, that plus that. Yeah.
At the same time.
Yeah.
Something electrical?
Yeah. It's the air conditioning.
Oh.
And again, this is where we were talking to the design engineers. They go, no, that's got nothing to do with that. And then they looked at the design, and then we realised that the wiring for these three things were all next to each other under the floor. So even though, I guess it's like, I don't know, the skeletal system and the digestive system, they might not necessarily be related, but the wires of these two ones heated up and then heated up that wire, which was a larger wire, but yeah, so that pattern then made sense. So it sort of shows how data science can pull out the unexpected.
Yeah.
And then that's just a quick example. This is what airlines see. So each of those rows is a flight, and you'll see a series of red and yellow little heat map things, and they would then click on that and go, why is that flight red? And it would take you to a screen saying this and this have failed the last 3 times, etc. So that's what the product looks like. Oh, sorry, I realised I've only got 5 minutes. So very quickly, we've sort of touched on this before. In a balanced team of data scientists, there's a lot of different skills that a balanced team would need, because at the very start we need people who can munge data and put data in a place that makes it accessible, or create a space for very big data that might not normally work on the normal system. You've hopefully seen today a visualisation specialist is pretty key. It's often the skill that gets the data science team sort of acceptance in the organisation, because it's accessible to people, it makes sense, and they don't get scared by models and whatnot. So visualisation is really key. So I've got there statistician, mathematician, skills in machine learning and AI, but that's often what happens in universities is that department takes over the data science, and the software takes over the data science stream. And then lovely to have would be if you've done some consulting experience, some communication experience, and also some business, like talking the language of the business or knowing the industry. Okay, so the themes is that, I think we have to be able to combine multiple data sources. The way of the world now, data's coming in different forms, not just numeric data. And a very important skill is data engineering. ETL is extract, transform, load. If you haven't, that's a common theme in the industry, and data munging. More use of open source tools I've covered. People wanting instant gratification. I think that's where the dashboards and the visualizations come up. So you may have worked, for months with this model, but what people want to see is this instant, sexy, for want of a better word, and wanting self-service tools and dashboards. A thing I really drum into my teams in industry is that 80% solution's okay, and for some of us that have grown up being trained in a really pure way, it's very hard to let that go sometimes. And we need a combination of skills to be a successful data scientist. And what the industry is looking for in their job ads is a combination of skills. And that's it. And I made it. 3 4. Yeah. Thanks, guys.
Everyone.
Thank you.